Okay, today we're going to take a look at properties with isosceles, equilateral, and right triangles. And the two angles adjacent to the base of an isosceles triangle are called the base angles. Remember that the base is the non-congruent side in the isosceles triangle. And the angle opposite the base is called the vertex angle. Okay, the base angles theorem says if two sides of a triangle are congruent, then the angles opposite them are congruent. And then very similarly to that, there's also a converse to this, which states that if two angles of a triangle are congruent, then the sides opposite them are congruent. So when you have two sides congruent in a triangle, there are going to be two angles that are congruent as well. What that leads to then are two corollaries that say if a triangle is equilateral, it's equiangular, and then vice versa. If a triangle is equiangular, it's equilateral. So all three sides and all three angles are going to be the same. Okay, so when you have a triangle and you have two sides equal, the sides opposite of those two, or the angles opposite those two congruent sides, are going to be the ones that are the same. And those are our base angles. Okay, so the base angles are not necessarily at the bottom, it's the one that crosses the two sides. Now, if HG is congruent to HK in a triangle, okay, these two segments here are equal. Then what that means is that angle G down here and angle HKG are going to be the same. We have to use HKG because there's two angles at K. And then similarly, if you have angle KHJ congruent here with angle KJH down here, then the two sides across from them, which is HK and JK, are going to be congruent also. Okay, so when you have a side that's congruent, the angle opposite it is congruent, or if you have an angle that's congruent, then the sides opposite of them are the same. Okay, here's some examples with this. Triangle ABC is isosceles, angle B is the vertex angle. And if B is the vertex angle, that means that angles A and C are congruent, and as a result of that, AB and BC are the same. So, if B is the vertex angle and angle A is 4x plus 2, that is going to equal angle C, which is 2x plus 20. All this is asking us to do is to find x. So we're going to subtract the 2x from both sides. So we have 2x plus 2 equaling 20. We subtract our 2 from both sides. So 2x is 18, and then x will be 9. Now, keep in mind that B is the vertex angle, so that's the one that's not congruent. Okay, so in this same problem we've got up here at the top, okay, B is still my vertex angle. Now B is x. Remember that A and C are the same. A is 2x plus 5. Well, that means that C is going to be 2x plus 5 also. And now, in order to find x, we're going to take all the angles and add them together. So these three angles have to add up to the triangle sum of 180. So x plus 2x is 5x. 5 plus 5 is 10. So our equation becomes 5x plus 10 equals 180. And from there we subtract 10 from both sides. So that 5x is 170. I'm going to take 170 and divide it by 5. X is 34. Make sure you know which angles are the same. Okay, because with B as the vertex angle, this is the non-equal side, or not equal angle. Okay, now, same kind of problem applies. We know that B is our vertex angle, so we know that angles A and C are congruent, which means that BC and AB are the same. Now, if BC and AB are the same, then these two things here are equal. And this AC piece is just a distractor, it doesn't matter. So 5x minus 3 is going to equal 2x plus 9. We'll subtract 2x from both sides. So 3x minus 3 is 9. We'll add our 3 back to the other side. So 3x is 12, and our value for x is 4. Again, the question only asks us to find x, so we don't have to find any missing angles. Now, the next example we've got, we have two angles that are equal. And the two angles that are equal are across from these two sides. So it helps you to draw lines from your equal angles. Do that so that you know what two sides are the same. So 5x minus 6 is equal to 3x plus 12. We'll subtract 3x from both sides. So 2x minus 6 is equal to 12. From there we're going to add the 6 back. So 2x is 18. And our value for x is 9. Equal sides creates equal angles, and vice versa. Now on this one, we have two sides that are equal. So that means that those two angles down here are going to be the same. So 2x plus 5 is going to equal 3x minus 45. We'll subtract our 2x from both sides. So 5 equals x minus 45. We'll add the 45 back. So x is 50. Okay, again, equal sides create equal angles. When you have two angles that are the same, or two sides that are the same, remember that if you draw lines from the sides, you're going to hit two angles that are equal. Okay, this gives us the base angles theorem. So for number 1, our value for x is 70. On number 2, okay, this side down here is going to be equal to this. Okay, so my angle at the bottom is 45. So the two angles that I do have are 90. So that x and that 90 add up to 180. When I subtract the 90 off, my value for x is 90. Okay, so again, that's the base angles theorem, and its converse. Equal sides creates equal angles. Okay. Here's another couple examples. Again, with the sides, these two sides here have to be equal because our angles are the same. So 6x minus 1 is going to equal 23. We'll add our 1 to both sides, so 6x is 24. And 24 divided by 6 is 4. Over here, the sides that are equal go to these two angles here. So 6x plus 4 equals 58. Subtract 4 from both sides, so 6x is 54. And if I divide 54 by 6, my value for x is 9. Okay, now for these two problems, I want to find the value of x and y. On these two problems, these two angles are the same because those two are equal. So I know that x and y are both the same. Well, if I take 180 and I subtract 50, that gives me a 130 degree angle, 130 degrees for both x and y. And since x and y are both the same, then we're going to divide both those by 2. And our value for x is 65. And our value for y will be 65 as well. Okay, again, equal sides creates equal angles. Here's another one. Okay, my two sides that are equal are these two here. So that tells me that y is going to be 42. So now to find my value for x, I'm going to take 180 and subtract 42 plus 42. Okay, which is 84. And that is going to give me 96. And that's equal to my value for x. Just keep in mind again, in addition to equal sides creating equal angles, the angles in our triangle still have to add up to 180 no matter what. Now, when you get into equilateral triangles and equal angular triangles are going to be the same. So if you look at the picture you've got here on a board, all three angles are equal, which means that all three sides are the same. So you want to pick the one that's probably the easiest for you to solve. In this case, I think it's 2x plus 4 equals 16. Okay, so I'm going to subtract 4 from both sides. So 2x is 12. That means that x is 6. But my reality is that I could also have said that 4x minus 8 equaled 16. Again, I'm going to add the 8 to both sides. So 4x is 24. My value for x was 6. Or I could have said that these two were equal. So 4x minus 8 could have equaled 2x plus 4. When I subtract 2x from both sides, I have 2x minus 8 equals 4. When I add that 8 back, 2x is 12, and x is 6. In summary, when you have an equilateral triangle, it doesn't matter which two sides you compare. But remember that you only have two sides that have to be equal in order for the triangles to have a value for x. It just doesn't matter which set of sides you pick. Now, when you do have an equilateral triangle, keep in mind that all your angles have to be the same. Because if all three sides are equal, then all those angles there are going to be the same. So in order to find a measure of angles P, Q, and R, I just have to take 180 divided by 3. And the measure of angle P is going to be 60, the measure of angle R is going to be 60, and the measure of angle Q will be 60. The same kind of thing will occur when we look at the lengths in a triangle. Okay, if all three sides or all three angles are the same, then every side here is going to be the same as well. So ST is going to be 5, as would SU. Now, things that can occur with this, that develop with these, become different kind of things with angle relationships, like this kind of triangle here. Now, if you take a look, you're going to notice that all these angles here are 60-degree angles because this triangle is equilateral because all three sides are the same. Which means that our value for x right here has to be whatever x plus 60 is equaling 90. So I'm going to take 90 and subtract 60. My value for x is 30. But these two sides here and here are the same also. So that means that my angle up top is 30 as well. So now, my two angles in green add up to 60 degrees. When I take 180 minus that, I get 120. And that is equal to my value for y. There are a lot of different comparisons now that you can toss in there. You also could have found y being 120, because remember that those two angles have to add up to 180 degrees there as well. Okay. You may see something like this where we've got all the sides the same. Okay, we've got to find different side lengths. Okay, our very first one here with y, it's an equilateral triangle, so our value for y is 4. But since this triangle here is equilateral, my length from end to L is 4 as well. So now when I want to find my value for x, this x plus 1, because these two sides here are the same, equals 4. So we subtract 1 from both sides, and our value for x is 3. Okay, the equilateral triangle at the left-hand side allows you to know that NL's length had to be 4. And you can put the x plus 1 in there. Okay, here's one final example with angles. Now, with this picture, okay, these three sides here are all equilateral. So that tells us that each of these angles here, here, and here are 60 degrees. So I know that x is 60. Now, down here in this corner, this angle is 90 degrees. So that means that this angle here is 30. Okay, that's across, and this side is congruent, and this side is congruent. So this angle here is 30 also. So I have 180 degrees again, subtracting 60, and that gives me 120, and that will be my value for y.